quantitative approaches to forecasting. Now we can group the quantitative approaches into two groups. One is called time series models, and we will be discussing 4 different approaches. And then we have what is called associative model. The difference is in time series model we will only look at the sales data from the past, whereas in associative model we look at sales data along with other factors that have an influence on sales, like price, advertising expense, competition, maybe unemployment rate, some other economic indicators. So that's the reason why it's called associative model. There are some factors that in association may influence demand. So we will study the relationship, the associative relationship between those factors and sales using linear regression. So that's associative model. Whereas time series models are only dealing with sales data alone. No other data is used. So what is time series? Time series is simply a list of data observed evenly spaced over time. So it could be daily data, it could be weekly, it could be monthly, it could be any time frame, but as long as it is evenly spaced and regular intervals of time, okay, observations are made at regular intervals of time, no missing values, then that would be a time series. So it could be like noon temperature every day, or it could be rainfall every month. But of course we are interested in demand, so it's going to be demand data from the past arranged in a specific evenly spaced, time-wise evenly spaced numerical data. So that's time series. Now we can take that a time series and break it down into 4 different components. That is trend, seasonality, cyclical, and random component. So let's look at each of these 4 different components. Now trend is a long-term gradual increase in the data. So that is called trend. So there is a gradual increase, so that's called the trend component. Now within each cycle, it could be years, it could, if it is years, it could be like monthly ups and downs or quarterly ups and downs, seasonality, so Christmas season and summer and winter and so on. So these repeat cycle after cycle after cycle. So that's your seasonal component. Then cyclical component is gradual ups and downs caused by economic considerations, economic factors. And random component is everything else that you cannot associate with any particular reason. So trend component is persistent overall upward or downward trend, and this is caused usually due to population growth, new technology, aging, and cultural factors, and it is typically over several years of duration. Seasonal component is regular ups and downs. It could happen week-long and daily season, or month-long weekly season, or month-long daily season, or year-long quarterly, year-long monthly, year-long weekly seasons repeating. So in the first case there are 7 seasons. In the last case there are 52 seasons. Cyclical component is repeating ups and down movement because of caused by business cycle, political economic considerations, factors, and so on. Random component is the residual fluctuations due to randomness that we cannot foresee. Now, depending upon the type of fluctuations that are present, different modeling approaches would be appropriate. So if you take a case when there is no trend, no seasonality, only random fluctuations, okay? If there are only random fluctuations, then we can use naive approach, and moving average approach, and exponential smoothing approach. There are 3 of them. So naive approach is simply that you take the previous period's actual demand and use that as the forecast for the next period. So for example, if January sales was 68, then you use 68 as the forecast for February. So it is the most simple approach. So if you want to use any other approach, that any other approach must have a higher level of accuracy, lower level of error. So naive approach is kind of a benchmark. So any model that you consider should beat the naive approach, otherwise that model is no good. Might as well use naive approach. Now moving average, on the other hand, is to take a certain number of past periods and average them, maybe 3 periods, 2 periods, 4 periods, 5 periods, and average those and use that as the forecast for the next time period. And so here is the example of moving average. So a modified moving average is weighted moving average. You apply weights to the previous number of demands that you use, 1, 2 periods or 3 periods or 4 periods. You associate weights and then compute the weighted moving average. So here is an example of weighted moving average. We'll work class problems in a little bit in the next video. So potential problems with moving average, though increasing the number of periods that you average, okay, will smooth the forecast and it will become less sensitive to the immediate increases and decreases. On the other hand, if you decrease the number of months that you or number of periods that you want to average, then that would become very volatile and it will change depending upon what's actually happening in the actual values. And it does not, of course, moving average is only for random fluctuations. It does not do trend well, it does not do seasonality well, and it requires extensive historical data. So here are some graphs of moving averages, how moving average will act. So actual sales, there is always a delay in terms of moving average catching up with the actual sales.